All right, we're on page 4 of Calc C Notes 8, I think. Yep. I didn't even look. Yep. We're talking about alternating series, and we want to, I don't know, just keep going. So we talked about the error term. Error is first term left off, assuming it's convergent alternating series. Alternating series error is like the best. I can't stress that enough. Someone says, like, find the error, your first thought should be like, does it alternate? Because if it does, I'd like to do that. If it doesn't, I'll do it, but I don't want to. Approximate the value of f3 using the first 3 terms. Lame. All right, f of 3 approximately. All right, plug in 0. If I plug in 0, what is this function? I think we know this function. I don't know. I may be jumping the gun here because it probably like asks later, maybe. If you peel this apart, or what are we doing? The opposite of peeling it apart? Bring it together, maybe. You can make this negative x squared to the n over n factorial. I think this is e to the negative x squared. I think we're dealing with e to the negative x squared. It's e with negative x squared plugged in. I think that is true. But anyway, so plug in 0 and you get 1, 1, 1. So you get 1. Plug in 1 and you get minus x. You know what I should have done? It's not too late. Not too late. Let's like write it out. F of x is approximately 1 minus x squared over 1 factorial plus x to the 4th over 2 factorial. Okay, good. Yeah. And now we're going to plug in 3. So minus 3 squared over 1 factorial plus 3 to the 4th over 4 factorial. Kind of, 2 factorial, sorry. I got caught up in the exponent there. The excitement. Okay. It's kind of hard to believe at the outset that E things converge because like 3 to the 4th is pummeling 2. But like eventually it's going to lose to the factorial. Factorials grow really fast. This is my approximation. Could use a calculator. It doesn't really matter. Find a bound for the maximum of. Now this thing looks insane. F of 3, the true value, right? F of 3 is the actual value. Let me highlight that. This is the actual value. That's an arrow. Actual value. And then this thing, this is our approximation. So we're finding the difference between our approximation and the true value. What is that? That's the actual error, right? So if the true value is 5 and our approximation was 4.5, the actual error would be 0.5. We're off. All we can do is find an approximation for it. So I'm going to say that this thing, if I go to infinity, so I'm just going to borrow this and say if I went to infinity, the sum from n equals 0 to infinity of negative 1 to the n, 9 to the n. 9 is 3 to the 2n, right? 3 to the 2 is 9 and then to the n. N factorial alternates, has terms that decrease in magnitude, and the limit as n approaches infinity of 9 to the n over n factorial is 0. Okay, so I'm just establishing that it's a convergent alternating series. Therefore, converges by AST. So the absolute value of f of 3 minus the sum. This is a weird way to write this. 0 to 2 of negative 1 to the n, 9 to the n over n factorial is less than the first term left off. So what was the first term we left off? Well, if I 0, 1, 2, right, to get this, and plug in 0, 1, 2, plug in 3. So it'll be 9 cubed over 3 factorial. Plug in 3. Yeah, okay, 9, which is 3 to the 6th, which is why it looks different from what I wrote. But it's that. To what, we cheated already. Okay, so to what common function? So we said the sum from n equals 0 to infinity of negative 1 to the n, x, so what, 9 to the n? Is this gonna be a different function? 9 to the n, what is happening? 9 to the n, no, 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 no. Silly, silly. This is x to the 2n over n factorial is e to the negative x squared, as per our discussion above, when we ripped it apart and then we just wrote it down. So we'd already done that part. So is it going to ask us to do anything? No. What? Come on. Okay. You know what we should do? We should look at this on the calculator. I don't know why it's not asking that, but like if we were in person right now, I'd be like, yeah, let's look at this on the calculator. So let's do it. All right. So what are we going to do? First of all, let me define, well, f of x I think is e to the negative x squared. Okay, I'm going to say g of x is the summation thing. And what do we want to go to? So n goes from 0 to, well, if I just do 2, I guess, negative 1 to the n, x to the 2n, n factorial. So this is going to be a bad approximation. So if I do like f of 3, and if I do g of 3, so it's pretty far off. E to the negative x squared, negative 1. 3 is really far from 0, and 2 terms is like a super bad number to use. So let's see. Let's go like 20. And do g of 3 with 20 terms. It's getting down there, but like f is so small. What would make this get? So I'm starting to doubt like that I got it right. So g of 3 this time. Okay, hold on, we're back in shape. So, well, yeah, look at the potential error. The potential error was 9 cubed over 3 factorial. So we could have been off by like everything. If you use 200 terms, though, way closer. All right, so let's do the thing we're supposed to do, though. Let's do, I'm going to redefine this. I'm going to find g of 3 based on this. Wow. So the true value should be in between, the error we got was 9 cubed over 3 factorial. This is like a horrible problem. So the true value is somewhere between, oh no, yeah. Our estimate minus our error, okay, and our estimate plus our error. The true value is somewhere in between negative 89 and 154. You can't tell me that it's not, because f of 3 is like right in there. It's very comfortably inside. So say we did 200 though, right? When it was defined as 200, and then I did g of 3, way closer, right? So 200 terms. So what would be the first term left off? It would be this with n equals 201, right? Okay, whatever that is. I'm going to plug in 3 such that x equals 3 with a decimal. That's the error. Oh, look how close you are. That's like so 0 that I don't think the calculator could even deal with it. So this approximation is like super, super accurate. Our estimate when we only used 3 non-zero terms was garbage, which is what happens, right? So the more terms, the better. The closer to the center, the better. It had a lot not going for it. So here's a graph of f of x. Here's a graph of g of x, which I think currently has 201 non-zero terms. And you can see it's going to take like forever to fill in. Should I just let it go? Oh, maybe it never fills in. Oh no, there we go. There we go. Really good on some interval. Eventually, if you go to infinity, an infinite number of terms, it'll like converge entirely. You can see this is, honestly, I don't know what it's doing. I mean, it's still working, so that's good. Like, what are you? Like, what's this little point way out here? I'm gonna try to get back to the notes. Let's see if I can do that, because I think the calculator is frozen right now. So this often slows down my computer to the point of being useless. Bad problem, because we didn't use enough terms, and because we're so far from the center. The center is 0 and we're at 3. Terrible. But we got an interval that worked, right? Between negative 89 and 154. Like, yeah, 0.0123 or whatever, right in there. So that happened. All right, let's see. We have to write down the 4 essential series that we have memorized. So I always start with sine. Sine of x is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus dot dot dot. I guess plus negative 1 to the n, x to the 2n plus 1. You got to memorize these. Got to have them available all the time. Right? When I looked at that series before, I was like, oh, I think this is e with something plugged in. And the reason I knew that was because I have these memorized. And I saw the n factorial in the denominator. That was the tip off. 6 factorial plus dot 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 plus negative 1 to the n, x to the 2n over the quantity 2n factorial plus dot dot dot, plus dot dot dot. E to the x we just used is 1 plus x squared over 2 factorial x cubed over 3 factorial plus dot 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 plus x to the n over n factorial plus dot dot dot. And then 1 over 1 minus x, the geometric, which is, it's a really important series. Like it's the weirdest of the like non-series version, I guess, I think is geometric. But then like in terms of series, it's the, I mean, look at that. Look at that. X to the n plus dot dot dot. This one, however, only works for the absolute value of x less than 1. For what values of x will each series alternate? So sine and cosine alternate for all, I think. So sine of x, cosine of x alternate for all x. So that's, I mean, it's just alternating. It doesn't matter what you plug in there. Sometimes it'll alternate negative, positive, or positive, negative for sine, at least. Cosine, it's always going to alternate positive, negative, positive, negative. E to the x, when x is less than 0, will alternate, I guess. E to the x for x less than 0. And then the geometric also alternates for less than 0. So e to the x and 1 over 1 minus x. So I don't know what I'm doing. 1 over 1 minus x for x less than 0. So I think that's right. I get that wrong in class almost every year. So like now I have like just like a mental block about it, but I'm pretty sure that's right. Like I think that's how it works. Anyway, we're done with this. So I'm gonna come back in the next video and do some more. And I hope you find this helpful, and I will see you there.